Hey everyone, in this video let's take a look at question 46, permutations on Leetcode. This is part of our Blind 75 playlist on Leetcode. So let's begin. So in this question you're given an array nums of distinct integers and you want to return all possible permutations. You can return them in any order. So whenever you see something like return all or generate all, any types of these exhaustive type of questions, you want to think of recursion, more specifically backtracking when it asks you to generate all types of things. And this question is actually very similar to subsets question. And honestly, it's going to look pretty much identical. A lot of it will be the same because a lot of these types of backtracking questions are basically the format is exactly the same. And you just have to tweak a couple of things in certain types of questions to make the solution correct for this one. So let's kind of just go through this one. And if you haven't seen the subset problem, like watch that one because it's going to be pretty much similar to that one. So I'm going to kind of skip over a lot of the like basic stuff. Because in subset, I really went through it like in 20 minutes or so. So a lot of the topics there just carry over here. So make sure you watch that one. But anyways, let's just kind of see how we can form this, right? Like what exactly do we notice here? Well, first of all, we notice that for each of these outputs, they have the same elements as the number of as nums, right? So it's not like subset in which this might have 0 elements, whereas this has 3, this has 1, whereas this has 3. First of all the elements in the output have the same number of elements as the input, which makes sense. Second thing we notice here is that kind of if you think about it, like if it was just like 2 items, right? Like the item was like something like this, then the answer would be 1 and 2 and 2 and 1. So kind of like duplicates are allowed here if you think about it. So it's a more generic version of this one where duplicates are allowed and the numbers and the items like in the output, they have the same amount of elements. So that's another thing we notice here. But other than that, like if you think about it, we're kind of just going to be calculating it using the same type of approach, right? So for example, let's consider something like 1, 2, 3. Initially, we would start off at 1, right? And then we would add that to our current permutation list, and then we would recurse. Now, here's the question. Where would we recurse on? Because on subset, we recurse to the next element. And there's a very important reason we did that. We did that because we didn't want any duplicates. But if you really think about it here, we do want duplicates, right? Because if we have 1, 2, 3, or let's just keep it 1, 2. If we had 1, 2, then we want to form 1, 2 and 2, 1, even though these are exactly the same. If you think about it, where should we loop to next in our next recursive call, in our next recursive stack? Where should the loop counter start at? Well, if you think about it, it should actually start at 0, right? Because any time we're doing this recursive call, it's possible that we are just going to be flipping the items. In this case, we have 1, 3, and 2, whereas here we have 1, 2, and 3. Now think about this. If we were at 3, then it would make sense for us to go back to the 0th index, right? And then consider 1, and then, oh, we see 2 isn't there, so we add in 2. And then that's how we finish our loop. So that's kind of like the idea, and maybe we can put it in code, and we'll see if it makes more sense, and I'll go through it at the very end to just hone it in. But as I said, this question is going to be very similar to the subset one. And kind of the way we do these types of question is you have like a result variable, and then you have your helper call, which basically generates all of the sublists, or in this case, like the permutations that you want to add to result. And then you print out result in the very end, or you return result. So here, what do we want to pass in? Well, as I mentioned, it will be the exact same as pretty much all the backtracking type questions. So we'll pass in nums, we'll pass in result, we'll pass an index here, and we'll pass in cur. Cur will be like the current set of permutations that we're forming. Now, one thing we need to differ here is in subset, we simply added cur to result right away. But if you take a look here, we only want to add when we're completely done a permutation, right? And the way we can basically figure that out is if the length of cur is the length of res, then we can add it. Not length of res, length of nums. Then we can add it. So we can do res.append cur, and again, we'll be appending a copy. One other thing we want to do is that if we've processed every single thing in nums, then there will be nothing else to do, right? Because we're already done the permutation. So here we can return. That differs from subset where we're gradually adding on more subset. That's why we don't return here. But here, if we are at this condition here, then there's no more to loop. There's no more to do. So then we return. Now here, we will do for I in range, index, and then length of nums, exactly as we do here. exactly as we do here. We'll append to cur. What are we doing here? We're appending the current item. So if we think about this in 1, 2, 3, right now we just appended the first item. Then I will do a recursive call, and I'll fill this out, and then I'll simply pop from cur again when we come back. So what should happen in this recursive call? If you think about it, nums will be the same, res will be the same. Index, let's figure out what index should be, and then cur, because we append cur here, cur will also just be passed in. Well, index, if you think about this, it should not be the index plus 1. Because if that was the case, then if we were somewhere like here, if we were, for example, let's just have like a bigger list, like 1, 2, 3, 4, 5, 6. Like let's say we're over here, then it's possible that one permutation actually starts at 4, and then the next element is something like 1, 2, 3. If we were to simply put on I plus 1, then we wouldn't have access to any of these. So that's why we have to start off at the beginning of the loop again. So actually here index would be 0. And if you can argue, you actually don't need index at all, right? Because it's always going to be starting at 0. But I like to keep index anyways because it allows me to just kind of follow my format of how I like to do these questions. So index here will actually start off at 0. Now, you may think, well, isn't this a problem? Because if we had something like 1, 2, 3, for instance, if we had something like 1, 2, 3, let's say we added in the 1, and then we did a recursive call, then we're back at the 1, right? So we don't want to add a 1 again. We instead want to go to the 2. We only went back to the front so that we can have like these reverse, like these duplicates basically. We didn't want to go back to the front so we can add the same element again. So what can we essentially do here? Well, if you think about it, we have access to cur. We already know what's inside of cur. So why don't we simply check what is already inside cur, and if this existing element is already inside of cur, then we won't add it. We'll just continue the iteration. If we do that, then when we go back, we'll skip the 1, we'll go to the 2, and then again we'll do a recursion. We'll go back to the front, we'll skip this 1, we'll skip the 2, and we'll add the 3. And then we'll go ahead and return, and then we'll pop. And then actually this one's also done, so we'll pop here. So now index is 2. So then we do a recursion, or before that we add in the 3. Now we do the recursion back to 0. And now you can see why we're going back to 0. Because we go back to 0, we skip the 1, but then index will become, I will become 1, and then we add in the 2. And so at this point, this is why we go back to the front, so we can have these kind of reverse type orders here. So in order for us to do this, we need to basically keep track of the elements that we've added. Now, you could do this in terms of simply checking. If num.I in cur, then we'll just continue the loop. We have nothing to do here. And that's basically all there is to this question. So what do we need to pass in? We'll pass in nums, we'll pass in res, we'll pass in the current index as 0, and cur will be an empty list. And again, in this question, it doesn't really look like we need an index passed in. And the reason it is erroring out is because, why is it erroring out? So let me see. Num.I in cur. If num.I is in cur, then let me just make sure I passed in these variables correctly. So nums, res, 0, and cur is empty. If length of cur is length of nums, then we'll append cur. Okay, that's perfect. And then for I in range, index to length of, not length of cur, length of nums. That's the problem. So once we do that, we should have the correct answer. Perfect. And then we'll just go ahead and submit it. Awesome, that's all we need. Again, you don't really need index passed in here, but I like to keep my template the same, so that's why I keep it here. What is the time complexity for this? Well, it just kind of helps by knowing that if you have a list of size n, then the amount of permutations you can form is n factorial. That's just a mathematical fact. And so because we are looping n times as well, the time is n times n factorial. And also the space, it's not really, I'm not sure what the space would be, I'll be completely honest here. It's a little hard to calculate in these backtracking type questions. But you can come up with like anything that makes sense, and you should be fine. Okay, thanks for watching this video.